Hi, we will talk now about the intervals of R. What's an interval of R? An interval is defined as being a part of R. So it's a subset. We say it's a subset. Donc it's a part of R, such that if this part contains any two real numbers, any two elements of R, it means that any number between these two elements is in the subset. For example, if I take all the numbers between -3 and 0, and then all the numbers between 1 and 3. This part of R is not an interval because you can find two numbers. The first one is, let's say, in here, and the second one is in here, such that the number between them is not in this part, in this subset. So if A represents all the numbers that are between 3 and 0 and the numbers between 1 and 3, A is not an interval because not any number between two numbers of A is in A. But if I take, for example, all the numbers between -3 and 0 only, this is an interval because any two numbers that you choose between -3 and 0, let's say -2 and -1, if you take a number between them, it will be in A, in the part A. Okay, so an interval is a part of R such that any two numbers that you choose for all x, y in this A, any z you choose such that z is between x and y, then z will be in A. Okay, so of course you are used to write, for example, 1, 3, union 4, 5. This is something you are used to write. So this is not an interval, it's a reunion of two intervals. Okay, R plus is an interval because if you take two numbers in R plus is equal to all the real numbers which are positive or 0. If you take any two positive numbers or 0 in R, any number between them is in R plus. So R plus is an interval. But R star that is equal to all the real numbers except 0 is not an interval because if you take two numbers, if they are positive, any number between them is in R star, it's fine. If they are negative, any number between two negative numbers is in R star. But if you take one positive and one negative number, not any number between them is in R star. 0, it's the case of 0. So let me insist on the point that for all x, y that you choose in A, this should be true. Any two numbers, not you can find two numbers, any two numbers you choose in the part A, any number between them should be in A. So this should be true for any number. So R plus is an interval, but R star is not an interval. Okay, so this is the definition of an interval in R. If we go to the course, I will define the segment. So the segment first is defined as follows. If we take two numbers A and B, two real numbers, such that A is less or equal to B, then AB is all the numbers x such that x is between A and B. Let me explain a little bit this expression. When I want to represent a set, I can write it like this. I open these brackets and then inside I will put x belongs to R, so it means all the elements in R, comma means such that, or I can put this sign which means such that. So here I put what numbers can be tested to check if they are in the set or not. So all the numbers in R should be tested such that they verify a condition. So here I put the condition x is between A and B, and this is the condition. So this way of writing the set is an explicit way where, again, I put here all the elements that can be tested if they are in the set or not, and here is the condition that they should satisfy so they can be considered in the set. I'm talking about. So AB is all the numbers in R that satisfy X is between A and B or equal. Okay, so I will denote it AB with a closed bracket. This is the segment. Okay, so it's all the numbers between A and B with A and B included, because here it can be or equal to A and B. Now, I will write it a little bit differently. I will say that an element of AB, Z belongs to AB. This is the sign for belongs. It's used when I'm talking about an element from one side and a set from the other side. I'm saying that this element belongs to the set. It's an element of the set. Is equivalent. It's the same thing as saying that Z is equal to 1 minus Tx plus Ty, T between 0 and 1. In fact, this is a way of writing things that you will come across many times this year. It's saying that if you take X, you multiply it by this number, and Y you multiply it by this number, you will find a number that is between X and Y. Because let's take it a little bit differently. T is between 0 and 1. For example, if T is equal to half, if T is equal to half, this expression will be half X plus half Y. So it's X plus Y over 2. It's the midpoint of XY. If you take T equal 1 over 3, for example, it will be like 1 over 3 times Y, 2 over 3 times X. So it's something that is more close to Y than to X. If you take the two extremities, for T equal 0, you will have X, and for T equal 1, you will have Y. So this expression, if you replace T by any value between 0 and 1, this expression in here will give you all the numbers between X and Y by varying the T. Okay, so this is we say it's the equation of the segment AB. So this is the same thing as this expression here. Now, I will define again the interval that I talked about. We say that I is an interval if and only if any two elements you take in this I, for all A and B belonging to I, such that A is less than B, then the segment AB is an I, which is what I said before. The segment AB is an I. It means that any element between A and B is an I. And this is the definition of the interval. And using this definition, we can define 9 types of intervals. This one that we call the closed one, where the extremities are inside the interval. This one, which is the open one, which is all the elements between A and B without A and without B. This one, which is a semi-closed interval. It's closed on A and open at B. It means that it's all the elements with A but without B, all the elements between A and B with A without B, and etc. Also, when we talk about intervals of R, we can never find a closed interval with infinity, because infinity is not in R. It's in R bar, what we called R bar. And when we write A plus infinity, we want to point out all the points that are greater than A, and etc. Okay, and minus infinity plus infinity, of course, it will be R. So be careful about how we write these expressions in here. It's the X in R such that it's here, it's such that X is between A and B and can be equal to B in this case and not equal to A in this case, and etc. Also, one can write that R plus is all the positive elements between 0 and plus infinity, included 0. R minus as well, the negative elements with 0. When we add the star, it means that we remove the 0 from the interval. Finally, if I take two numbers and I take the two numbers A and B and I calculate A plus B over 2, I call this the center of the interval, because it's the midpoint between A and B. Now, what about the absolute value? What's an absolute value? The absolute value of a real number X is the positive version, if you want, of X. So if your X is positive, its absolute value is the same. And if X is negative, its absolute value is minus X. For example, the absolute value of 2 is equal to 2. The absolute value of 3 is equal to 3. But I want to ask a question: how an absolute value can be negative X? How it can be minus X? But it's positive always, no? Yes, this is true if X is negative. So it's the absolute value of minus 3, it's 3, which is negative of x. This is the x. So when your x is negative, its absolute value is minus itself. Let's check some properties for the absolute value of x. First, the absolute value of x is always positive, of course, because if x is positive, it's equal to x. If x is negative, it's minus x, so it's always positive. The absolute value of x is equal to 0 means that, and it's equivalent to x equals to 0. When I say equivalent, it means that it goes both ways. So if absolute value of x is equal to 0, it means that x is equal to 0. And if x is equal to 0, it means that absolute value of x is equal to 0. So it goes both ways. This is always true, of course, because absolute value of x is equal to x or minus x. In both cases, if it's equal to 0, means that x is equal to 0, and it goes the other way around. Now, any x you choose in R, the absolute value of x is equal to x if x is positive, or equal to minus x if x is negative. It means that it's a positive version of x. So of course you have x less or equal to its absolute value always. And also something very easy to interpret as well is that if you take x and y, two elements in R, the absolute value of the product is the product of the absolute values. And this is true also because if your x and y are both positive, or if x and y are both negative, and if x and y are one positive and one negative, anyway, the product will be, the absolute value of the product will be the same as the product of the absolute values, because the product of the absolute values, you remove the signs, you are positive only, and then you do the product. And the other one, the absolute value of xy, is that you multiply x and y, and then the absolute value will take care of the sign, and it will be positive. So it's the same thing. Now we have the two last inequalities that I will prove in here. First, the triangular inequality that says that if you take x, let me put this white. So if you take x, y in R, then you have x plus y in absolute value less or equal than absolute value of x plus absolute value of y. Why is that? First, let me take the first term, x plus y squared. If you're watching the video, please pause it and try to do it yourself, and then come back and see the proof. But I will continue it right now. So the x plus y squared is equal to x plus y, of course, times x plus y in absolute value, because it's the square of the absolute value, which is equal to the absolute value of x plus y times x plus y. Why is that? Because of the property number 4, which is equal to the absolute value of x plus y squared. This is something positive, then its absolute value, it's equal to x plus y squared. And x plus y squared, it's of course equal to x2 plus y squared plus 2xy. Now, the x2 that's in here is equal to the absolute value of x2, of course, because it's positive. And then, due to the property number 4 as well, it's equal to x times x, which is equal to x times absolute value of x. And this is the property number 4 in here, in fact. Okay? And which is equal to the absolute value of x squared. And also, the absolute value of y squared is equal to y squared as well, with the same procedure. And these are the two first terms. And then I have the xy. xy, in fact, is less than xy. And this is due to the property number 3, of course, which is equal, due to the property number 4, to x times y, each one in absolute value. Which means that 2xy that I have in here is less or equal to 2 times absolute value of x times absolute value of y. Therefore, if I go back to this expression in here, this one being equal to this one, I will have absolute value of x plus y squared less or equal, because instead of x2 I will put absolute value of square of absolute value of x2. Same for y2, because I already proved that it's equal as well. But for the xy, I will replace it by 2xy in absolute values, 2 absolute value of x times absolute value of y, which is greater than 2xy. So it's less or equal than absolute value of x squared plus absolute value of y squared plus 2 absolute value of x, absolute value of y, which is x plus y in absolute values. I will write it clearly. So it's absolute value of x plus absolute value of y squared. We remove the square on both sides. We do a square root. They are positive. Then we will have the property. So this is the triangular inequality, the property number 5. Now if we go to the property number 6, we need to prove that for all x, y, and r, the absolute value of x minus the absolute value of y is less or equal than the absolute value of x minus y. In fact, we can write that the absolute value of x is nothing but the absolute value of x minus y plus y. So we didn't change anything. We removed y and then we added y, which is less or equal, due to the triangular inequality number 5, to x minus y plus y. Okay? So, which means that if we take this y to the other side, we will have x minus y less than x minus y. What do we need to prove? We need to prove this. What does this mean? It means that x minus y in absolute values is from one side less than absolute value of x minus y, and on the other side it's greater than, or equal, of course, both, greater than minus absolute value of x minus y. And so what we did here is to prove the first side of the inequality. So now we can do the same, but replacing y by x, and we will obtain absolute value of y minus absolute value of x less or equal to x minus y, which is the second part of the inequality, because if we multiply by minus, we'll have the second part. So this way we can prove the property number 6. Let me point out something. What I wrote in here, I will explain it in here. So if you have, for example, x minus 3 in absolute value less than 6, it means that if x minus 3 is positive, we have x minus 3 less than 6, because absolute value of x minus 3 is equal to x minus 3. And if x minus 3 is negative, we have absolute value of x minus 3 equal minus x plus 3, which means that it's minus x minus 3 less than 6. So x minus 3 greater than minus 6. So combining both, we can write that x minus 3 is between minus 6 and 6, and this is something that you should know. And this is what I applied, and saying that the property can be rewritten as absolute value of x minus absolute value of y is between minus absolute value of x minus y and absolute value of x minus y. Now to finish this part, I will go talking about the distance in R. What's a distance in R? When we define the numbers, we put them in a given order on the axis. Therefore, we'll define a distance, which is the magnitude of the, if you want, the length of the segment between two numbers x and y. So I defined the distance between two numbers x and y as being the absolute value of x minus y. Why it's absolute value? Because what I need is the amplitude of the distance between x and y, or the length of this segment, without looking if x is greater than y or y is greater than x. Okay, what interests me is that the length of this segment. That's why first, the distance that I defined is positive, first, because it's an absolute value. Of course, the distance between x and y is equal to the distance between y and x, because absolute value of x minus y is equal to absolute value of y minus x, it's the same thing, because the absolute value of a number of the negative of this number, it's the same thing. Then if the distance is equal to 0, which means that x minus y is equal to 0, due to the properties of the absolute value, it means that x minus y is equal to 0, then x equals to y. And finally, we have this transitivity, which translates the triangular inequality. In other words, if you have the distance between x and z less than the distance between x and y, and then plus the distance y and z, it means, or it can be deduced from the triangular inequality by writing dxz is equal to the absolute value of x minus z, of course. Due to the triangular inequality, writing this as being x minus y plus y minus z, I subtract y and then add y, it will be less than x minus y plus y minus z, because if I consider that this is the first number, big X, let's say, and this is big Y, the triangular inequality will allow me to write this. So this is how we prove it using the triangular inequality.